Welcome back. Today we'll look at paper 13 of the October-November 2023 series. And as always, since the mark scheme is available online, then I will recommend checking that as well as just watching this video. And if the video is too slow, then I'd recommend watching at 1.25 or 1.5 times the speed. Okay, question 1 says, state what is meant by analog data. So I think for analog, well, we can say what is going to be a continuous signal. So yeah, or maybe let's say a signal, right, with continuous values. And then when we say continuous, well, let's put in brackets, we'll just say non-discrete. Although, yeah, non-discrete, I mean, well, I guess kind of, yeah, by saying it's continuous, obviously that means it's non-discrete anyway. So hopefully people know what continuous and discrete mean. Of course, let's say we have data, for example, age. Now, age can, of course, only be discrete because, well, it can be, 1, 2, 3, yeah, obviously, etc. I mean, well, obviously, it doesn't just have to be an integer, right? It could be, I guess you can say height, although, yeah, height is not really the best example. If we imagine height is rounded to, let's say, 2 decimal places, well, in that case, you say yeah, I guess it kind of is discrete. Because, well, let's say their height can be, I don't know, like 1.7 or, yeah, 1.71, right, etc. But if it's continuous, well, then, of course, we can have any value. We could have, let's say 1.7, let's say like 5, 7, 8, yeah, of course, it can just keep going. Right, so that's going to be the thing. Analog is going to be continuous like this. Yeah, it's not going to have to be quantized or rounded up or down to a given value like digital data is. Right, then draw one line from each term to its most appropriate description. So we've got sampling, well, sampling rate or sampling frequency. Then finding the sampling resolution, right, also called the bit depth. So description, the number of samples taken per second. Well, that should just be this one, right, the sampling rate or sampling frequency. Taking measurements at regular intervals and storing the values, well, that's going to be the process of sampling. And of course, well, one of these measurements is going to be one sample. Right, then the number of bits used to store each sample, again, right, that's going to be the sampling resolution or bit depth. And I mean, just to draw a quick picture, or yeah, quick kind of graph, we say, well, the sampling resolution or bit depth, that's going to be how many values there are. Well, I suppose not how many values there are. Of course, yeah, this is how many bits we use to represent each sample, but it's going to correspond to how many values there are on the on the y-axis. So, for example, let's say we have a sampling resolution of, I don't know, maybe 4. Well, that's going to give us 2 to the 4 different values, which equals 16. So, effectively, I don't know, let's say we can have 0, right? Maybe we would then want to have, let's say, like 5, right? Then we have 10, right? Then, obviously, yeah, it keeps going. So, basically, like, we're only going to have 16 different values. Now, of course, if we had a sampling, let's say a sampling resolution of 24, well, then we're using 24 bits per sample. Right, and I think this one is going to give us about 16 million. Yeah, roughly 16 million. So of course, then, well, we've got so many more values like this, or yeah, so many more quantization levels, and of course that means that, well, the sound is therefore going to be more accurate. I guess what it's going to be more accurate representation of the original input analog signal. And then likewise the sampling rate, well, that's just going to be the x-axis. So of course, if we have a low sampling rate, right, maybe we take one sample here, one sample here, one sample here, right, one here. Of course, well, yeah, well, let's say the digitized sound that we stored is not going to represent the analog signal very well. Whereas, of course, if we're taking more and more samples, so if we have a higher sampling rate, well, then of course we're going to get a more accurate representation, right, of the original analog signal. Right, so then 2, we want to describe the impact of increasing the image resolution on the quality of a bitmap graphic. For this, I think we can say that if we increase the image resolution, then that means we're going to have more pixels to represent the image, right? Hence, the image will become less pixelated. And the reason for that is that, well, let's say we have this image, I don't know, maybe 100 by 100. And like here, well, let's actually sort of decrease the resolution just to sort of show the opposite effect. Then of course it's kind of easy to imagine, right, going the other way. Because I don't know, like, well, let's imagine this is our input for, I guess, yeah, maybe our kind of input photograph, right, from the camera. Of course that's going to be a much higher resolution than this. But let's imagine we're storing this as like a 10 by 10 image. Well then, what we've got to think is what we're going to say that each of these, so we're going to take what, a 10 by 10 grid, and then we're going to take this, 10 by 10 subgrid, right? We would then take the average of that, and then of course we would take this average color, right, and then store this as 1 pixel here. Then we would take another 10 by 10 subgrid, right? Of course, yeah, that would then be the next pixel. But obviously, yeah, then we take another, 10 by 10 subgrid, right, so on. So of course, yeah, that's why our image is going to look really blocky because, well, we're not getting those fine details. So yeah, let's try and say that. We can say, yeah, I mean, obviously, while we said increasing already, I don't think we have to say it again. Right, let's just say, yeah, the image quality will improve, or yeah, increase. And I suppose let's say since, alright, so since we have more pixels, or yeah, since the image contains more pixels. And alright, yeah, let's say like this means, right, this means, and well, let's say the image will appear more detailed. Yeah, right, so let's say, right, more detailed / less pixelated. Okay, yeah, pixelated. And of course, again, that's for this reason we've described here. Right, next we want to calculate the file size of the bitmap image using the following information. Right, image resolution, yeah, 2048. So what that's going to be 2 kibibytes. Well, I suppose, yeah, not kibibytes. I mean, well, maybe sort of kibi pixels, if you want to, yeah, say that. Of course, the next one, well, this is just what, yeah, I guess like 1 kibi. Right, then a bit depth of, well, 16 bits. So I mean, this one I kind of hinted at already. Like the way I do it, and well, I think the way you should do it is you just want to represent it in terms of I guess kind of like multiples of kibi. So if we think, well, 2048, right, that's going to be 2 times 1024. Yeah, for this one here. Right, then of course we're multiplying by, well, I guess that's going to be the number of rows. Right, then we also want to multiply by 16. Because if we think, well, the file, yeah, the formula for an image size was going to be the number of pixels, okay, which is just, well, the resolution, right, the rows times the height. Or I guess, well, yeah, sorry, the rows times the column. And of course that will give us the number of pixels. Right, then we multiply by, well, what's the size of each pixel, right, and of course that's going to be 16 bits. Right, then if we want to give our answer in kibibytes, well, I mean, so right, I guess we can say, this one here is going to be bits. So to go into bytes, well, first we have to divide by 8. Right, then we also want to, well, right, divide by 1024. Yeah, to go from, well, in this case, bytes, right, into kibibytes. And of course, then we can just start cancelling. So I guess this 1024, that can cancel here. Right, and then I suppose, well, then we've got 2 times 16, so that's going to be 32. And I guess 32 divided by 8. So we can also just write this, this is going to be 4 times 1024. And then, well, I guess just divided by 1. So yeah, 4 times that is 4096. Yeah, just hoping sure I've not made any sort of cancellation or simplification errors. Okay, number 3, a company sells online computer science courses to students in different countries. The courses are stored on a public cloud, and explain why the company uses a public cloud to store these courses. Okay, so I guess, well, with a public cloud, of course, they can be accessed anywhere. So let's say what the courses right, can be accessed right, by, well, let's say by students anywhere in the world. And then, I mean, since it's the cloud, I guess you can say this provides the convenience of, well, obviously, yeah, they don't have to manage their own servers. They don't have to worry about doing updates and maintenance, security, right, all that kind of stuff. So we can say, right, yeah, also, right, let's say the cloud, yeah, okay, also, right, the cloud, right, provides the benefit of, or let's say, yeah, maybe the benefit of, I don't know, we can say like easy, kind of what easy setup. Right, let's say setup slash maintenance. Yeah, and I guess well, yeah, since the user doesn't have to do this themselves. Yeah, because well, again, obviously that's going to be handled by the cloud company. Yeah, I guess what maybe setup, right? Let's say maintenance and also let's say updates. Yeah, so I think that should be okay. All right, and then yeah, if we go on to the next one, so well, now we want to describe two disadvantages of storing data on the public cloud compared to storing data on a server in a local area network or LAN. So I think, I mean, I guess one since it's a public cloud, of course, where you have to trust this company. So let's say what privacy or security. So yeah, we have to trust the cloud company. Yeah, right, we have to trust the cloud company, right, with our data. And then I guess what, so maybe let's say, yeah, why LAN might be better. So we can say in contrast, and what we'll say, yeah, files are stored, well, I guess locally on a LAN. Yeah, files are stored locally. Right, let's say, yeah, on a LAN. I mean, yeah, that's kind of in the name, local area network. Right, I guess we can say what, hence we have full control. Yeah, let's say full control over them. Right, and then I think too, I mean, you can probably just talk about cost. I mean, a LAN, well, if you've already got the hardware, then, I mean, basically the LAN is going to be free. Like, of course, I mean, if you have to actually buy a server, well, of course, yeah, you have to pay for that, right, the initial purchase. But actually, I mean, the cloud is actually, well, I mean, to me, I would say super expensive. Like, some people can pay like hundreds or even thousands of, well, let's say dollars, just for like even quite a small website. And yeah, that's going to be monthly. Right, so let's say, yeah, price. Right, let's say a LAN is, well, cheap slash free. Okay, yeah, well, let's say free, right, if we have the hardware. Alright, yeah, let's say if we have the hardware already. I guess, well, yeah, or just requires a one-time yeah, alright, let's say, yeah, or just requires a one-time purchase of hardware. And I guess, well, let's say again, in contrast, let's say what the monthly, yeah, let's say the monthly cloud payments will be more expensive in the long term. Yeah, and I mean, actually, I think there's kind of many like stories of this, where, let's say for example, I don't know, someone has a website, and someone tries to, well, let's say attack the website by maybe uploading like thousands of files. I don't know, like they just want to create some sort of simple script in a loop, right, just to upload, sort of like 1 GB files repeatedly. And then, well, let's say the website owner, right, well, I guess they wake up the next morning, and suddenly they log in, they see their bill, and like suddenly they've got a bill for, I don't know, like $1 million worth of storage. Yeah, just because, well, one, they've set no limits on it, and yeah, obviously two, well, because I guess because the cloud has this kind of auto scaling property, where like obviously, well, the more data that people are uploading, I guess, yeah, your instance is just going to get bigger and bigger, and of course, therefore, the price is going to get more and more expensive. Same for something like let's say like a DDoS attack. The cloud is just going to keep scaling and scaling, right, to handle this DDoS attack. But yeah, then of course, well, the price is going to get more and more expensive, or yeah, the cost. Anyway, number 3, we want to state how the following security measures can be used to protect computer systems. Right, so firewall, I mean, I think these are just simple definitions. Let's say this can inspect incoming and outgoing packets. Yeah, right, so inspect, right, incoming and outgoing packets. Yeah, well, let's say, well, to the network. And we can say, well, and choose to accept or deny them, right, based on a set of criteria. Yeah, let's say choose to accept, right, deny them. Or let's say based on criteria. Or yeah, based on a set of criteria. And I think, I mean, well, if you've seen the other videos, we talked about this many times. Right, yeah, set of criteria, okay. And you can also say, well, for example, right, that can be IP address, so maybe you want to block this IP address, or yeah, even block this range of IP addresses. And like often they'll do that, right, maybe they want to block like an entire country. Then of course, well, they can block all IP addresses from that country. Same, for example, you can also block based on protocol. So like if you see someone and they're trying to access like FTP, right, file transfer protocol, well, maybe you want to block that. And yet instead you only want to allow, well, let's say HTTP, right, or HTTPS traffic. Anything else like, I don't know, maybe FTP, SSH, right, let's say like SMTP, right, that's well, I think send message transfer protocol, or it's just an email one. Yeah, you could say, all of these other ones, right, they're going to get blocked, and we only want this one protocol, for example. Likewise, you can block based on the port number. Right, then encryption, I guess here we can say, I mean, I think, a word they use will scramble. Yeah, so this will scramble the data. Right, so yeah, scramble the data, or I guess we can say what the... Yeah, I mean, I was going to say plaintext, but I think we can just say here data. I guess we can say in brackets, well, plaintext. Right, let's say into ciphertext. Right, and let's say, well, so even if it is intercepted, it can't be understood. Yeah, right, okay, even if it is right, intercepted, right, then I guess what it can't be understood. Right, then the last one, passwords. Okay, so what we can just say, maybe used to authenticate users. Yeah, let's say, right, maybe authenticate users yeah, into accessing, right, a system / parts of a system. Yeah, I think, right, into a system. Right, hence, I guess, yeah, unauthorized people. I mean, I suppose this is kind of obvious, right? I mean, unauthorized people won't have access. I mean, we're kind of just stating the opposite of what we said here. Yeah, I guess, well, let's say, right, unauthorized people will be blocked. Yeah, I think that should be okay. B says the company uses the database courses to store data about the courses and their tutors. Right, each course starts at different times of the year and may have a different tutor. The database has, well, the following structure or schema. Right, there's the course information relation that has a course ID primary key, then description and cost, right, fields. Right, then, well, the tutor relation has the tutor ID primary key, right, telephone number, email address, right, tutor name, yeah, three additional fields. Right, then the course schedule relation or table that has the course ID and date started, right, as a composite primary key. So composite because, well, it's using both of those, both of those fields as the primary key. Right, then also a tutor ID. And we want to complete the entity relationship or ER diagram for this database. Right, now, I mean, for this, there's kind of two ways you can really do it. Of course, if they give you some information, well, of course, use that. Right, other times you also want to try to identify the foreign keys. So I think one foreign key, if we see this course ID, right, that's going to be a foreign key to this course ID. Right, well, this tutor ID, yeah, that's going to be, well, let's say a foreign key, I guess, to this table. And yeah, of course, well, this course ID is a foreign key, you know, obviously, well, to this table, right, this relation. So if we look at the first bit of information, right, each course starts at different times of the year and may have, alright, so yeah, just this one, right, different times of the year. So what we can say probably, if we think, let's say an example of this course schedule, like you could have something where, let's say you have course ID 1, right, course ID 1, course ID 1, right, then let's do 2. And like, I don't know, maybe the first one is May, right, maybe the next one is June, yeah, the next one is July. So in effect, what we're saying is that, well, we can have, yeah, well, okay, so if we look at this one, I guess what one course information can have many different schedules. So yeah, let's just do a one-to-many like this. Right, now if we look at the tutor, we can kind of think something similar where, let's say maybe this one is tutor 1, right, this one is tutor 2, and then maybe July is, you know, back to tutor 1 again. So here then what we're saying is, well, one tutor can also have many different schedules, because yeah, it's linked, right, by this foreign key. And yeah, I mean that's kind of what it tells us here, right, that yeah, I guess each course may have a different tutor, but I think we're also saying that, well, the same tutor can teach, you know, multiple different courses. Yeah, I mean that, yeah, okay. Right, so then we want to write the structured query language or SQL script to return the total number of courses that have started after the 9th of September 2023. Right, the value returned must have an appropriate field name. So right, when it says appropriate field name, well, this means they want us to use as, and yeah, obviously I'll show you this one. Right, but then when we want to return the total number of courses, well, here then we can probably just use count. Like there was, I think, another question where it wanted us to return the total, and that actually needed sum, because I think in that case, well, it was the quantity. And for example, let's say here, well, this one sold like 7, right? This one sold 5 or something. So of course, well, here, right, the sum is therefore going to be 12. But here we're actually, yeah, we're actually just counting the individual number of courses. Like we're not actually summing a column like this. Right, so what do we need? We want, right, so I mean, well, obviously we're looking for the date. So yeah, I guess here we're going to need this date started. And I think this one then we can do just using the course schedule relation. Alright, so let's go select. And right, what do we want to select? So let's select the count. And I mean here, well, we can just say, what is it? I mean, so actually, you know, for this count we can use either, right? We can use the course ID, date started, right? Even tutor ID if we want. I mean, probably just, let's just use the course ID, right? Since it's the first one. Do they have, okay, yeah. So I'm just checking to use, you know, the correct capitalization. Right, so the problem is if we just select this, well, then it will literally just say, you know, count course ID. And then I guess under that it will give us our value of like, I don't know, maybe 15 or something. But, you know, what we want is, well, like we just want to rename this field heading, right? That's what it's saying. So in order to, well, rename the field, then we just say as. And I mean, okay, so when I say rename the field, like I'm not talking about actually like changing the name in the original relation. I'm just talking about renaming, like just for this output. Like of course, if we run it again, well, like it's still going to have the course ID, right? It's yeah, just for this output that we're changing. So I don't know, like let's call it maybe, yeah, num courses, or yeah, number of courses. Right, then we want to say from. Right, so from, and that's what the course schedule. Right, and that, well, then I think we just want where. So yeah, we're just going to say what, where date started is greater than, yeah, greater than 9th of September. That's right. So yeah, let's go where. Right, that's going to be date started. And then in SQL, well, we could just use, you know, greater than, less than, right, greater than or equal to for dates. So let's go what, greater than, and then I think this should be inside quotes. Let's go what, 09, let's say 09. Yeah, so I think, yeah, September is month 9. Right, and then let's go 2023. And I think this should be the format where it's going to be, well, date, yeah, then month, all right, then obviously we'll have 4 years like this. Okay, right, an example of a tutor ID is this: an administrative officer enters the tutor ID into the tutor table. Explain how data verification can be used when the tutor ID is entered. Right, so when they're talking about verification for data entry, I think for this there's going to be two. There's the visual check and double entry. So yeah, let's mention both of those. Right, probably 1 mark for the name, 1 mark for the description for each of them. So yeah, let's say a double let's go. A double entry check can be used. Yeah, and I guess to ensure they entered the sort of tutor ID twice. So all right, okay. Well, let's say this will require the user to enter the data twice. I guess that's kind of obvious, really. But yeah, I don't know. Let's say it anyway. Right. So yeah, this will require the user. Yeah, and I mean, like, sometimes they say, well, just one user. I guess, you could also do it where you have 2 users. So yeah, different people entering the data both times, right? And that's going to be sort of even better, because like maybe, I don't know, like maybe instead of a 1, right, this person accidentally read it as like a capital I, or yeah, maybe they misread it as like an L or something. And of course, like if you've sort of made a mistake once, well, you're actually quite likely to make the mistake again, because obviously, yeah, you're just going to sort of type it in quickly. You're going to rush, right? You're not really going to look at it that carefully. Whereas if you have 2 different people doing it, then yeah, of course that's going to be more accurate. But I think here, well, let's just say 1, right? So this will require the user to enter the data twice. And then we can say, and the system will sort of check them to ensure they're equal. Alright, so yeah, let's say and the system, right, or and the computer, right, will check them, right, to ensure both values are equal. And I mean, double entry. Well, an obvious example is a password. A lot of websites and things, they'll say type in your password, when you sign up. Then of course you have to re-enter your password again, right? Yeah, just making sure you haven't mistyped it. Right, so the system will check them to ensure, what the user, let's say that the user has entered the same value twice. Okay, well, hang on, right, let's say, yeah, to ensure both values are the same. And I guess if you wanted, you could mention, this is even more kind of reliable, right, if you have, 2 different people. I guess, yeah, if you have a different person doing each entry. Right, let's say the next one, or maybe also, yeah, so also a visual check can be used. And we say, this is where, so, this is where the, let's say the user, or I guess, the officer, right, this is where the officer would enter the data. Right, yeah, enter the data. And then we can say, and manually compare their entry, with the sort of correct value, sort of, on paper, or, sort of on the other screen or something. Right, so that, they would enter the data and manually compare their entry. Right, yeah, I don't know, like with the desired value, I guess. Yeah, and I suppose, I mean, since it's visual, or let's just say, right, by looking at them, or yeah, by looking at both of them. Yeah, and I guess if you want to be more specific, you could say, I don't know, like, and comparing them character by character. Right, okay, so then write a truth table. So yeah, write a truth table for this logic expression. Yeah, so I mean here, this one's a bit nasty, right? They've got a lot of brackets, so we have to make sure to do this in the correct order. So I guess, first then we want to do this, right? Of course, then we're going to XOR it. But before we XOR, first we actually want to do this inside the brackets. Yeah, then of course this one, right? Obviously, yeah, then we're going to XOR them together. Right, then we're going to do the and not p at the end. So it's a bit annoying, right? They don't really give us much space, so I'm going to write it kind of vertically like this. Right, so that's going to be p and q. So I'm just going to look for the rows where it's true. Now, of course, and is true if both of the inputs are true. So here, well, 1 and 1, right, 1 and 1. And then, of course, everything else is therefore just going to be 0. Right, now if we look at, well, I think, yeah, now then let's do not q. So, yeah, all right, well, let's write out not. So not q, well, that's going to be 1, 1. All right, then 0, 0. Yeah, 1, 1 and 0, 0. Of course, yeah, well, notting, right, 0 becomes 1, 1 becomes 0. Right, then, well, then we're going to just do this ORed with R. So here then, if we look, well, of course, OR is going to be true if, well, let's say at least one of them is true. So here, well, 0 or 1, right, that's going to be true. Right, then again, well, that's true, right, this is false, that's true, 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 right, false and true. Right, then we want to XOR them, so we're going to be XORing this one, and what we're XORing it with this one. So we, well, when we XOR, if they're different, it's going to be 1. So here, well, 0, yeah, 0 XOR 1, okay, that's true. Again, 0 XOR 1, that's true. Right here, they're the same. Right, yeah, different, 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 right, different, and the same. So yeah, well, 1 XOR 1, right, that's going to be 0. Right, then we just want to go and not p. Okay, so, right, if we go not p, well, obviously, yeah, not p is just going to be, hang on, right, not p, well, just what, 4 1s, and then, yeah, just 4 0s. And then if we AND them together, well, so, yeah, this one and this one. Yeah, so, yeah, this one and this one. And then here, well, we can see, right, there's going to be 4 zeros. So, yeah, of course, right, these can all be zeros. And, yeah, I think hopefully that's correct, right, as long as I've not made a silly mistake. Now we just want to draw a logic circuit for that logic expression. So let's just start then left to right. We want P and Q. And yeah, I'm just going to give myself space here in case I need to like jump over the wires. Right, so I guess like maybe then let's do these, or yeah, we could do the XOR if we want. So maybe let's just do the XOR. So of course XOR, what we're going to have this extra line, right? Then we have the kind of OR like this. Right, then we want not Q. So yeah, I'm just going to sort of have that coming out of there. Right, then we want, well, OR R. So yeah, let's try to sort of draw that. Okay, and then I think we said, well, this one should go into this XOR. Right, then we just have AND not P. So yeah, let's just do that. Let's do the not P here, and then we can just add these together at the end. Yeah, that should be okay. And of course, you know, as with any of these, right, like if your sort of drawing is not that clear, right, yeah, of course you can just like label them like this. Yeah, just to sort of let the examiner know what they're showing. 5 says a programmer uses an integrated development environment or IDE to develop a program that monitors air quality. We want to describe the following features of a typical IDE, right? So context-sensitive prompts and also single stepping. Now for these I have just opened IntelliJ here, right, just to demonstrate these. And yeah, actually hang on, let me just zoom in a bit. Right, so I mean hopefully people can see, well, this is just bubble sort, and I guess, yeah, you probably, well, yeah, you can also see the name here. Now right then, well, the first one, right, context sensitive prompts. So let's say here what we've got this array. Now if, for example, we just do numbers and then we do dot, well, here it's going to tell us, you know, all of the methods, all of the properties we can use. So yeah, I mean this is just going to be what context sensitive prompts are. Basically, well, just giving you code suggestions, right, as you're typing. And then the next one, well, single stepping. Now here you can see this red thing, right, I've added a breakpoint. So if we just run this in debug mode, what this is going to do, right, it's going to execute until this breakpoint. Okay, and yeah, if I just make sure to run the right program. Right, so it's going to run that until this breakpoint. And if we look here, right, it's going to be super small. But we can see here in this thing what's called the report window. Now the report window, of course, well, we can see the values of the variables. And then, right, if we just go single step, so I think, yeah, maybe this one. Right, then it's just going to execute statement by statement. And of course what we can see is, well, we can see how these variables are actually updating, yeah, as we're kind of running this. And of course, yeah, you could just, you know, run it to completion. And obviously, I mean, the benefit of doing that is, well, that's going to be easier to actually find the errors, right? Because you can find what specific line is causing the error, you know, what the values are, yeah, when the error is occurring. Right, so context-sensitive prompts, I mean, let's say this one, this will be, what, code suggestions. Right, let's say code suggestions provided, right, as the user is typing. And we can give an example, I don't know, like e.g., right, let's say what functions, procedures. Yeah, we can say identifiers, right, etc. Yeah, I mean, like, well, really, obviously, an identifier, that's just a name. So an identifier, well, that can be the name of a function, the name of a procedure, right, the name of a variable, constant, yeah, record. So I guess actually, like, identifier would actually include functions and procedures, to be honest. Right, anyway, so the next one, single stepping. I mean, we can say, what if, yeah, I suppose actually, I mean, this one doesn't really need a breakpoint. I mean, let's say during debugging, because I mean, single stepping you're not going to use, you know, for the actual final like release version or production version. Yeah, it's only going to be when you're testing. Right, so well, during debugging, yeah, let's say what single stepping can be used. And let's say what, to execute one line at a time, or yeah, to execute, well, I guess one line, one statement at a time. Okay, yeah, to execute, right, let's say one line at a time. Alright, let's say hence. Yeah, hence makes it easy. Or, okay, alright, let's say, right, hence allows the user, or, well, the programmer. Right, it's going to allow the programmer to inspect the values, right, at that particular point of the program. Yeah, let's say maybe to inspect the values of variables, right, slash arrays, etc. Right, yeah, okay, variables, right, slash arrays, yeah, let's say etc. Right, at that point in the program. And I guess we can say what, therefore they can find what line is causing the error. Or, yeah, I guess, I don't know, or maybe, yeah, this allows them. Right, let's say, yeah, this allows them, right, to more easily, right, let's say, find the cause of the error. Okay, then the program is distributed by downloading the source code and its library files from a web server. Explain the reasons for compressing the files. Okay, so let's say what, since it will use less space on the web server. Okay, yeah, since it will use right, less space, or I guess we can say storage space. Yeah, okay, right, less storage space on the web server. Right, we can also say what will be quicker for the user to download. Yeah, is there one more? Right, so quicker for the user to download. I guess what, and we can say what, and I guess, well, yes, since, right, okay, so right, let's say since it will require less bandwidth, or yes, since it's a smaller file size. Let's say, right, since it requires less bandwidth. And then we can put in brackets what this also makes it cheaper for the, I guess what the, yeah, what the owner of the, okay, alright, yeah, let's say it also makes it cheaper for the programmer, right, the owner of the web server. Yeah, I guess, alright, so yeah, this, alright, let's say also, alright, reduce costs. Or we can say what, reduce sort of bandwidth costs. Right, let's say for, I guess, I don't know, yeah, web server admin or web server owner. So obviously in that case, well, that's just the programmer, right? They're not talking about a company, I don't think. Okay, then the program files are stored on a new hard disk after they've been downloaded. Right, describe the reasons why a hard disk formatter is needed for the new hard disk. Okay, so I suppose, I mean, like if people are familiar, well, of course, yeah, if they buy a new hard disk, right, also if they reinstall their operating system, then one of the first things it will do is it will ask you, well, like which, let's say, which file system do you want? Like, yeah, do you want, for example, FAT, right, the file allocation table? Yeah, do you want, I don't know, like NTFS? Obviously, well, sort of Mac, Linux, right, they've got different, yeah, they've got different file formats too. So I guess, well, maybe we can say, yeah, to set up. Yeah, well, let's say to set up or choose. Right, to set up the initial. And I mean, I think here you can mention like the file allocation table. Alright, so let's say, yeah, file system. Okay, file system and its file allocation table. Yeah, I suppose, well, I know, like, to represent the file, okay, so I guess, well, the file allocation table, that's gonna, I mean, yeah, I don't know, like, maybe represent is not the best word, but basically it's just gonna have the data for where this particular file is stored on disk. So, I mean, yeah, let's just say to represent, right, the storage location, or, okay, we can say the physical location. Let's say the physical location of each file. And actually in brackets we can maybe put cluster. Right, yeah, on disk. Yeah, no, yeah, okay, right, so is there anything else we need to talk about? I mean, like, if it's new, I mean, of course, you're not really having to, like, sort of reset anything. You're not having to, you know, clear any data because, well, I mean, it should be empty by default. I mean, yeah, I guess we could say that maybe it will check for errors. So let's say, right, since it's new, yeah, there should be no need to, I guess, kind of reset. Yeah, right, so there should, or I guess, well, wipe, right, there should be no, okay, right, let's say no need, yeah, to wipe the hard drive. Let's say, however, right, a disk formatter, yeah, a disk formatter can be used to ensure there's no bad sectors, right? There's no problem with the hard drive. Yeah, right, let's say to ensure, or I guess we can say, yeah, ensure/handle bad sectors. Because, I mean, like, if there is a bad sector, you know, it doesn't really matter. But all that's going to happen is, well, that sector, yeah, if there's some, you know, physical defect with it, that sector will just be marked as unusable, right, in the file allocation table. So, of course, that will mean that, well, when you, like, save a file, yeah, I mean, basically, well, your operating system shouldn't try to write anything to that particular sector. Yeah, since we've determined that, of course, yeah, there's an error with it. Right, let's say you handle bad sector, I don't know, like issues or something, or yeah, locations. And just to go over an example, because yeah, maybe this is a bit complex. Now we can see here then, well, one, we've got this thing called a directory, directory table entry, and of course, well, that stores some metadata about the file, right, the name, the extension, right, some attributes. Yeah, I think maybe that's going to be the permissions. Of course, yeah, various other things. Right, the important one is going to be the first cluster. So this is, well, where is the physical location, yeah, of the file on disk. So here, I guess we're saying what it's going to start in this 4. Yeah, so it's going to start on, I don't know, like, let's say sector 4, for example, or yeah, I guess, well, cluster 4. And we say, well, this one then, right, then it points to 8. Because what we might have, well, you know, one file can, of course, use multiple clusters, right, if it's a big file. And if we actually look here, well, we can actually see the cluster sizes that we can choose. So let's imagine, I think the default is this 4096 bytes, right? So 4 kibibytes. Now, of course, if you've got a file that's, I don't know, like, 1 gigabyte, well, 1 gigabyte is then going to be, I don't know, probably like thousands or even like millions of clusters. So this is actually stored as a linked list, where here we say, well, the first cluster for this file is 4. Right, then we're saying the next cluster for this file is 8, which, yeah, we can see in this arrow, right, this is linking to 8. Right, then, of course, it's saying we go to 3. Yeah, then, of course, what 3 is saying go back to, yeah, go to here. And then I guess this EOC, I mean, probably like end of contents. Yeah, effectively just like the null pointer. And then obviously 3, well, this is going to be if it's unused. And then obviously, well, any other data that we want, if we want to add, let's say a new file, well, of course, yeah, we can put it in this 3 position. Yeah, so hopefully that makes sense. And like something that's actually a bit strange about this is, let's imagine you have a file that, I don't know, maybe the file is only 1 byte. Well, if you choose, let's say if you choose a, well, I guess here what they call it, allocation unit size. I think other places they would call it a cluster size, right, a sort of more technical term. So if you choose a cluster size of, well, here, right, 32-bit, 32 kilobytes, then even if your file is only 1 byte, or yeah, I guess just 1 byte, right, then it's still going to use 32 kilobytes on disk, where effectively, you're just going to have, well, your sort of file contents, and then the rest of it, well, it's just going to be, let's say, like all just 0 values, right, just all empty. So yeah, I mean, that's why if you have lots of small files, well, then you'd want to choose a small, I guess, a small cluster size, whereas if you have big files, well, then, I mean, yeah, then you can choose a bigger cluster size if you want, because I guess, well, bigger cluster sizes will be faster, right, since there's kind of, less jumping around in the linked list, right, there's obviously less, yeah, kind of like less, let's say less clusters or less nodes to actually like traverse through in the list. Alright, but if we go to the next one, so number 6, state 2 benefits to a programmer of distributing a program using a shareware license. Alright, so I think for shareware, well, what you can say is that obviously, well, because people can share it, then hopefully they can get lots of people using the program. Yeah, so I don't know, maybe let's say, right, since there is a free trial, yeah, since there is a free trial, let's say, right, lots of people can use the program. Or I don't know, right, let's say maybe, yeah, lots of potential customers, right, can use the program for free. Yeah, let's say, right, can use the program. Whereas, of course, if they have to pay for it first of all, well, maybe they wouldn't want to pay because they might think, yeah, I don't know, like, let's say maybe the program doesn't work as they expect, right, or it doesn't have the features they need. And I think another one you can talk about, well, if lots of people are using the program, then basically they can use these people as kind of like, I mean, let's say sort of testers, really. Yeah, so almost kind of like beta testing, really. So, yeah, let's say, right, if the program is widely used, right, let's say, yeah, if it's widely used, right, due to it being shareware, and we can say, what, yeah, these customers, or I mean, what you can say, like, sort of error, I guess error reports would be generated, right, for these customers, hence bugs can be fixed. Yeah, let's say maybe bug fixing becomes more easy. Okay, right, bug fixing becomes easier. And we can say, what, yeah, due to error reports, or yeah, okay, maybe due to automatic error reports. Okay, hang on, right, error reports, right, and user feedback. Yeah, and I think for this one, I mean, again, probably check the mark scheme, right, see what they say as well. Okay, then we want to explain why it's important for a program to join a professional ethical body. So I suppose what it can provide them advice. right, let's say, yeah, can provide, and I mean, let's think about what type of advice. I mean, obviously, it can be legal, right? Obviously, it can be ethical advice. Yeah, so I guess, well, let's say both, right? Ethical / legal advice. Yeah, right. Let's say, right, for their job. Right, let's say, yeah, job, right, / projects. And I guess we need to say what maybe when dealing with colleagues, for example. Yeah, I don't know, let's say like colleagues, right, or clients. Yeah, I mean, I'm trying to think, what we can write to fill up this whole space. So, of course, you could give an example. Like, maybe you can talk about copyright as well. Yeah, let's say maybe information about copyright. Yeah, let's say maybe copyright and different licenses can also be provided. Yeah, okay, right, and different licenses can be provided. Um, right, and yeah, I guess I don't know, maybe so I guess maybe and advice on what to do if I know someone is kind of stealing their right, like if they're stealing their intellectual property, I guess. Or yeah, I suppose, well, let's say, well, how to handle or yeah, how to deal with copyright infringement issues. Or well, let's say, right, intellectual property. Yeah, let's say, right, intellectual property, right, infringement issues. And then I think if we think of one more, I mean, another thing they often say, well, it's going to be training. Right, so that, yeah, let's say the ethical body can also provide, I don't know, sort of regular training, or yeah, I mean, probably not that regular, to be honest. Right, the ethical body, right, can also provide training. Right, to help the programmer. Yeah, and I mean, like, I guess, this is not really going to be sort of technical training, but again, you can say what, helping them with sort of any ethical or, yeah, sort of legal issues. Yes, I mean, hopefully that should be enough for 4 marks. Number 7, a laptop computer has static RAM or SRAM. A virtual reality headset and a laser printer are connected to the laptop. Right, explain why static RAM is used in the laptop instead of dynamic RAM. So if we think, well, the benefits of static RAM, I mean, well, let's say the main one is going to be faster. Right, however, disadvantage is going to be expensive. And I think it's about 100 times more expensive. So if you want, let's say, like 1 GB of dynamic RAM, I think people are saying this is like $50, right? Although, yeah, I think these days it's probably cheaper. Whereas static RAM, people are saying, well, it's going to be about 5,000. So yeah, okay, we say, well, static RAM, well, obviously it's faster. And you can also talk about power consumption. Now, actually, I think a lot of the mark schemes, they actually have different answers. Sometimes they'll say SRAM uses less power, whereas sometimes they say DRAM uses less power. And when I just searched this, I think the book also has different answers, yeah, between the different books. Also online, I think I saw 10 websites, on the sort of Google search results, and 5 of them said SRAM uses less, 5 of them said DRAM uses less. Now, I did find one answer, and this one seems to be good. And what they were saying is that when it's idle, because if we think, well, SRAM has sort of more complex circuitry, so that also means that if you want to store, I don't know, well, let's imagine you just want to store sort of like 1 MB, or yeah, I guess, well, 1 MB, then, the actual chip or the sort of physical size of the SRAM is going to be bigger. Whereas, of course, yeah, the sort of DRAM for storing that same amount of memory is obviously going to be smaller. So what you can say then is that, well, like, okay, I mean, when you're writing data, then SRAM is actually going to use more power. And the reason for that is because, I mean, basically, well, there's just more electronics, right? There's more transistors, yeah, it's more complex, just requires more power. However, with DRAM, if people know, I mean, basically, well, this is going to sort of kind of gradually lose power, right? The electrons are going to leak out. So what you have to do is, well, you have to constantly refresh that. So what you can say is, well, when SRAM is idle, right, when it's not being used, you actually don't really need, yeah, I think you need almost no power, right, just a really low current. Whereas, yeah, obviously DRAM, well, you need to constantly refresh it, you know, as we can see here. So I think, yeah, I mean, let's give that as our two examples. So, right, we can say, well, SRAM is faster. Yeah, faster. Right, and let's say, right, hence can be used for, like, e.g. the cache. Or I guess, all right, let's say, yeah, can be used, right, to store. And here we can say what commonly used instructions or data. Yeah, let's say, right, frequently used. Right, let's say instructions, yeah, and data. Yeah, let's say what, like, i.e. cache. So I mean, what we're saying is, well, SRAM is going to be used in the cache, right, also registers. Yeah, let's say also, so right, let's say SRAM uses less power when idle. Right, okay, yeah, uses less power when idle. And let's say, right, since it doesn't have to be constantly recharged. Yeah, since, right, it, right, doesn't. Okay, right, doesn't have to constantly be recharged. Yeah, right, let's say, yeah, like, I guess what like DRAM does. Right, then identify two reasons for using electrically erasable programmable ROM or EEPROM in a virtual reality headset. So the benefits then of EEPROM, well, one, we don't need any specialized hardware to actually, you know, write it or read it. Well, I guess just to write it. Because if you think, well, just the just the EEPROM, well, the EEPROM, this is the one using ultraviolet light. So to actually update this, well, first you need to kind of, let's say, disassemble the actual, you know, computer, or in this case, the headset. You'd obviously then need to actually physically take out this EEPROM. You'd then need to, like, put it into this sort of UV sort of laser machine, and yeah, obviously, this laser machine is then going to write it. And apparently this actually takes a long time, like even like 20 minutes just for the laser to actually sort of warm up and to, yeah, I don't know, just to sort of get ready, I guess. Whereas, yeah, if we look at this one, well, the electrically erasable programmable ROM, what we can say, maybe, or let's say, yeah, allows many rewrites. Or okay, or let's say allows us to update the firmware. Yeah, what we can say, without needing specialist equipment. Yeah. Okay, right, yeah, let's say without needing specialist equipment. Right, slash, I don't know, having to disassemble. Right, and then I think another one you can mention, like, if we have this, well, I mean, one, this will support many, like, reads and writes, whereas I think the other ones, like EEPROM, well, once you write it too many times, you know, it's just going to sort of wear away, because again, obviously, you're sort of burning it with that laser. Yeah, you can only have a certain amount of sort of burns with the laser. But I think another one you can mention that, yeah, so you can also say that, well, this one, if we just want to write, I don't know, let's say like one sector or kind of, you know, one block, well, we can just write that one block. Whereas if we're using this one, so again, with the UV light, well, we actually need to sort of erase the entire thing, right, and then just write it again. So yeah, we need to, like, rewrite the whole firmware, even if we just want to make, you know, one small modification. So let's say here, well, we can, or let's say we can update small parts of the chip without having to erase and rewrite the whole chip. Okay, right, so yeah, update, right, let's say small parts of the chip. Or rather than saying small parts, maybe you can say sort of, I don't know, like individual blocks. Yeah, let's say right, individual blocks on the chip. Let's say right, without having to erase and rewrite the whole chip. Right, then describe how the laser printer makes use of a buffer. Okay, so I guess here then we say what the pages would be sent to the laser printer. And of course, I mean, well, the actual printing process is going to be slower than, you know, the computer sending the data. So because it's going to be slower, of course, well, I guess you say what the pages will obviously build up in the buffer until it's full. When the buffer is full, well, then the printer can send an interrupt to the computer, right, telling it, or well, to the laptop, telling it to stop sending pages, right, stop sending data. And then, of course, well, I mean, obviously, well, then the laser printer is going to, you know, sort of print, right, continuously. And when the buffer is empty, well, then it can then send an interrupt to the laptop asking if there's any more data to send. So yeah, let's try and just explain that. Or let's say since, right, since the speed of sending, let's say, right, yeah, okay, or since the speed of sending pages, or I guess we can say data, right, let's say data and put in brackets pages, right, from the laptop, right, let's say, yeah, is faster than the speed of the laser printer printing. Yeah, I don't know, let's say what, I mean, I think just the speed of printing, or well, let's say, right, the speed of the laser printer printing. Okay, right, the laser printer, right, printing. Right, we'll say what then a buffer. Yeah, let's say a buffer is required to temporarily store that data. Yeah, okay, right, temporarily store that data. And I guess we can say what, when full. Yeah, so when the buffer is full. Okay, right, when the buffer is full, an interrupt will be sent to the laptop. Right, okay, sent to the laptop, telling it to stop sending. Right, I guess, well, let's say, so while, or yeah, maybe when empty. Right, when empty, yeah, an interrupt will be sent telling it to sort of send more. Right, an interrupt will be sent to the laptop. Right, let's say you're asking it to send more data if available. Right, so is that enough? So we said, well, the speed of sending is faster than the speed of printing. Right, I guess, yeah, if the, right, it's going to be temporary, yeah, sort of temporary memory. Right, yeah, when it's full, an interrupt, when it's empty, an interrupt. Yeah, so I mean, hopefully that should be enough for 4 marks. Okay, then we need to identify one port that could be used to connect the virtual reality headset to the laptop, right, and justify your choice. So I think for this, I mean, probably you can say USB, and I'd say also HDMI. They would probably accept as well. So I guess justification. Well, I guess we can say what the USB is universally. Well, I mean, since it's universal, obviously it's kind of accepted by many devices. Or let's say yes, since it's universal. Well, let's say yeah, many devices have USB ports and understand the USB protocol. Or let's say yeah, USB ports. Let's say and support, right, the USB protocol. And then I guess we can say what. So USB can also be used. let's say it can be used for both charging, right, and data transfer. And then I suppose, of course, if you're talking about HDMI, well, HDMI, I mean, what you can talk about, obviously, yeah, you're transferring media, right? So, well, video, sound, but like I don't know, I mean, like, would many VRs actually use HDMI? Because I feel, I mean, obviously, if you're like playing some game, you don't really want a cord connected to it, because yeah, obviously you're gonna like trip over and it's gonna create all kinds of problems. So I don't know, like probably most of them work by Bluetooth, I would imagine. Right, so yeah, USB can also be used for both charging, right, and data transfer. Right, question 8. Data verification is one method of protecting the integrity of data. Describe one other method of protecting the integrity of data. Right, okay, so this one's a bit confusing because, I mean, of course, when you think data verification, where you think, checksum, check digit, yeah, sort of various things like that. Of course, if it's during entry, right, well, visual check, double check. But I think here, they actually don't want us to mention a specific type of verification. They want us to mention the other one, right, so validation. So let's go data validation. Right, let's say can be used. Let's give an example. Right, so can be used to ensure the data looks reasonable, or yeah, to ensure the data is in a reasonable form. Right, to ensure, yeah, let's say the data, right, let's say seems reasonable. And yeah, I think reasonable, right, or yeah, reasonable, sensible, right, that's the word they always use for validation. Right, let's say e.g., and we'll give some examples. Right, let's say, yeah, the correct format, or well, the valid format. We can also say what type, or well, let's say data type. Right, let's say length, so obviously number of characters, right, size of the array. Yeah, well, I guess, we can mention range, right, we can mention presence, yeah, obviously, etc. Okay, then state one difference and one similarity between pharming and phishing. So I guess, well, maybe let's do the similarity first. I mean, both of them will be about trying to steal users' credentials. Yeah, okay, let's say like both are trying to... I mean, I don't necessarily want to say trick, because I mean, pharming is more sort of automatic. So I mean, let's say, yeah, trying to steal. Yeah, let's say steal user credentials. Yeah, or I don't know, like, or compromise their system in some other way. Yeah, I don't know, maybe compromise their account, right, / system in another way. Although, to be honest, I mean, stealing their credentials would really be the sort of most common. Right, then let's say a difference. Well, phishing is going to be achieved by sending emails that appear to be coming from well, let's say some like official company, or yeah, like a friend or something. But of course, yeah, it's like a fake email, right, from a sort of, well, yeah, not that person. Whereas pharming is more technical. Like that's going to be, well, let's say DNS cache poisoning, where someone actually like maliciously modifies well, your sort of DNS records, or yeah, the DNS server's DNS records. And therefore, when you ask, well, like, what's the IP address of, well, let's say, google.com, like, rather than telling you the real IP address of google.com, right, it's going to send back the fake IP address of google.com. So, of course, and, well, this sort of fake IP address, this will be, like, obviously, well, controlled by the hacker, yeah, who can, of course, then, like, have, let's say, a login page. And, obviously, rather than those login details going to, well, the real google.com, right, obviously, they're going to be going to your IP address instead. And of course, yeah, you would then save them in a database, right? Process them however you want. So let's say that, right? Well, phishing. Yeah, right. Let's say phishing uses what I don't know, maybe like fake or like illegitimate emails. Yeah, let's say maybe illegitimate or sort of scammy, right? Illegitimate emails. Right. I guess maybe let's say impersonating another person or company. yeah, I know. Well, let's say someone else, right? Because someone else could be a person, could be a company. Right, and then let's say farming. So, well, farming will modify, or let's say, yeah, modify DNS records. Or I guess we say, well, DNS records, like slash requests, right, to go to the malicious server or malicious website rather than the authentic one. Right, yeah, let's say so to automatically, because I think sometimes that's the keyword they have underlined or yeah in bold. Right, I'm just going to do more. So right, automatically, well, let's say redirect. Yeah, redirect to the malicious website. Okay, yeah, malicious. Yeah, I mean, I was going to say right, malicious website rather than the authentic website, but I think just saying yeah, redirect to the malicious website should be enough. Okay, then we want to explain how data security risks of malware can be restricted. Right, so I suppose, well, I mean, the obvious one is just going to be anti-malware. Yeah, so let's say what, maybe install like good anti-malware on the system. And like me, yeah, I guess since it says explain, well, let's explain how this works. Right, so yeah, this will use a database. Right, a database of known malware. Yeah, right, okay, well, so, all right, let's say, yeah, database of known malware, right, and heuristics. So heuristics just means behavior. All right, let's say heuristics of running processes. And then we can say, well, anything suspicious can automatically be, well, quarantined or deleted. Okay, right, yeah, so right, anything suspicious, all right, will be automatically quarantined. Okay, yeah, automatically quarantined, right, slash deleted. And I mean, just to give an example of heuristics, like let's say you've got some process that's I don't know, like maybe it's opening like millions, well, I guess not millions of files, but I mean, let's say it's just got, you know, scanning through your hard drive or opening all your files, then, you know, just immediately sending all of that data to some like external IP address. Now, good anti-malware, you know, can probably detect this because I mean, well, they can do things like detecting how many files, you know, the process has opened. Yeah, they can obviously, you know, see how much data, right, this process is sending, and in this case, well, that could be an example of spyware. Now you could have another one where, let's say, you have some you have some malware that's just like opening loads of files, right? Then it's modifying their contents. Then it's just, you know, saving them, closing them. Now, I mean, that could be legitimate, right? Maybe you're like legitimately encrypting all your files, but of course that could also be a sign, for example, of ransomware, where you've got some ransomware program that's encrypting all your files, right? Then they're going to say like, hey, in order to get the key, well, you need to pay us money. And then of course, yeah, once you paid them the money, right? Hopefully they would then give you the key back. Although sometimes even after paying them, right, they wouldn't give you back. Although to be honest, like most of them actually would, because you've got to think, maybe it's kind of strange, but to say like they actually have a reputation, you know, despite being, you know, cyber criminals, where like if people know that, hey, even if you pay them the money, they still won't let you get your files back. Well, then of course in future no one's going to pay them. Whereas yeah, if people think, well, hey, right, if we do pay them, right, they will actually, you know, give us the key. Yeah, then of course people are going to be more likely to pay them. So all right, and then I guess for the next one, I mean, we can just mention a firewall. Right, so a firewall can be used. Okay, right, firewall, yeah, can be used. Let's say what, to block, yeah, malicious incoming / outgoing traffic. Right, incoming, yeah, outgoing traffic. I mean, what we can also say passwords. Yeah, let's say strong passwords. Or let's say strong passwords that are changed regularly. yeah, that I change regularly, right, should also make it more difficult for a third party to gain access to the system. Yeah, okay, right, make it more, okay, more difficult. Right, and then let's say for a third party. Yeah, let's say, right, to gain access to the system. And I mean, yeah, I think for 3 marks, I mean, these should be enough. Of course, right, you can also mention, for example, backup, where you say, well, even if, malware does, sort of infect the system and sort of delete files, corrupt files, encrypt files, well, as long as you have good backups, right, then hopefully you can just restore, let's say to the current day, hang on, I guess not the current day, right, the previous day, or yeah, maybe the previous hour, depending on how frequent your backups are. Right then, the last one, a computer system is designed using the basic von Neumann or von Neumann model. Right, registers and buses are components in the von Neumann model, and identify 3 other components right in this model of a computer system, and do not include registers or buses in your answer. So, like, I will be honest, I mean, this one I did check the answer, because I mean, I was thinking, well, I mean, yeah, this model, I mean, it's going to say what input, output, then there's going to be memory, storage, and of course then there's going to be the processor. So, I mean, here, like, to be honest, I would have just said what input, output, right? I would have then said, well, let's say memory, storage. But yeah, like, surprisingly, they actually don't include those in the mark scheme. So I think they're kind of looking for things like sort of just inside the processor, really. So inside the processor, well, we can say the control unit. Right, we can then say what the ALU, the arithmetic logic unit. And then, I mean, so here, well, they call it IAS, right, the immediate access store. Like, to be honest, I feel a more common word is just cache. But let's say, right, cache / well, immediate access store. Because, I mean, well, really, they're just the same. Yeah, I'm not really sure why Cambridge actually call it this, to be honest. Yeah, because I think, I mean, this term doesn't really seem that common. Right, then we want to identify 2 differences between special purpose registers and general purpose registers. So, of course, well, special purpose, I mean, they're used for, well, a specific purpose. Whereas, general purpose, well, we can use, let's say, to store the output of calculations. I mean, yeah, obviously this is just kind of like restating the name, but I mean, I think they should accept it. Right, special purpose, let's say registers. I mean, I think, let's say, maybe can only be used for one specific purpose. Like, maybe it's possible to actually sort of overwrite them, but I think, yeah, probably it's not. And I guess there probably isn't many cases where you would want to sort of, maliciously overwrite them. Let's say, only used for specific purposes. Right, maybe can only be used for, maybe, let's say, their intended purpose. Right, let's say, e.g., well, if we think the program counter, let's say, storing the next address, or okay. Right, so storing the address of next instruction. And of course, other special purpose, well, you would mention, what you can mention, well, the MAR, MDR, CIR, right, status register. Right, I guess, I don't know, let's just have the semicolon, right, let's say general purpose. Right, general purpose registers can be used to store any data. Alright, and then, so I would say for the next one, I mean, let's say the programmer. So the programmer can access the general purpose registers, whereas, yeah, I think they shouldn't be able to access the special purpose registers. Now, of course, I mean, this could depend on, sort of different processors or different, processor families. But I think, yeah, that's usually going to be true. Right, so let's say the programmer can access, / manipulate the general purpose registers directly. Yeah, let's see what I guess the contents of the general purpose registers directly. Yeah, whereas obviously, well, for these special purpose registers, they can't. Now, of course, I mean, I guess they are kind of modifying the special purpose indirectly. Like, for example, well, I don't know, let's say we do LDD. Let's do LDD of 5. Well, when we do LDD 5, I mean, that's going to load 5 into the MAR. Right? I mean, when we're talking about the execution stage. So yeah, during the execution stage, well, 5 is going to be in the MAR. So I mean, kind of like indirectly, we are actually sort of loading data into these registers, or yeah, we are accessing them, manipulating them. But I mean, general purpose, we can literally just say, well, yeah, like put this value in the general purpose register. Whereas I guess here is sort of more indirect, because I mean, well, obviously what we're doing is we're calling this load instruction, unless it's kind of like a byproduct of this load using direct addressing. Yeah, it's kind of a byproduct that the MAR just happens to update to 5. Yeah, we're not really saying that directly. All right. Anyway, I think this is the last. Okay, wait, no, not the last one. Right, the following incomplete table contains the steps of the fetch-execute cycle and their descriptions. Right, so yeah, I guess we just want to write in the missing step using register transfer notation and the missing descriptions. Right, the address in the PC is incremented, so this is just going to be the PC, right, then the arrow, and then here what's going to be the PC, but we need to say, the contents of the PC plus 1. So what this is saying, we're loading the contents of the PC, right, maybe that's going to be the value 5, right, then of course we just plus 1 to it, yeah, then of course we copy that right back into the PC. Right, the next one, so I mean, this one's a bit difficult to describe, but I think what we can say, let's say the instruction stored in the address. Okay, right, hang on. So let's say the instruction at the address stored in the MAR is copied into the MDR. And I mean, yeah, so this one's going to be indirect addressing. Right, yeah, the instruction stored right in the address in the MAR. Or yeah, rather than stored in, you could say sort of pointed to by the address in the MAR. Right, is copied to the MDR. Okay, yeah, to that MDR. So let's just give an example then of how this works. Now, let's say for example we have address 5, and if we say the MAR contains the address 5, let's say in address 5, right, we have the value 3. Maybe in 3 we have some instruction like add 4 or something. So what this is saying, because the MAR value is 5, so let's just write that right, MAR equals 5. Then of course, we go to address 5, right? We see the contents of address 5 is 3. Therefore, of course, what we're doing, like now, I mean, now we kind of have this, where okay, we can say the contents for MAR is going to be 3, right? So like now, basically, we just have one bracket, and we're saying the contents of address 3, right? Well, that's going to be this add, and of course, yeah, that's then copied into the MDR. Right, so another description, what we can say, the contents of the PC are copied to the MAR. So yeah, I think this one, let's write quickly, right, contents of PC, let's say, right, copied, yeah, to MAR. Right, then the last one, the contents of the MDR are copied into the CIR. I mean, so this one's actually just the same, so let's get MDR, right, again, single brackets, yeah, it's using direct addressing, and that's going to be copied into the CIR. Okay, interrupts can be caused by software programs or hardware devices. State one cause of a software interrupt. Right, so let's say maybe a runtime error, and let's give an example. Maybe we can say, I mean, I guess one, they say divide by 0. Let's say maybe array index out of bounds. Yeah, I think I'm going to choose this one. Right, again, yeah, array index. Array index right out of bounds. So what this means is, let's imagine you've got an array, with the sort of bounds, right, or the dimensions, right, indexes, 1 to 5. But of course, let's say you try to access this array in element 6 or index 6. Of course, yeah, this is going to give you an error because, index 6 doesn't exist. Yeah, so I think they would be the other two. I mean, you could mention maybe some like data type issue. like if you're trying to assign a string. So let's imagine we do like ABC, and we try to assign a string right into some like integer variable. You know, let's call it n. Now for the last question, the following statements describe the stages that the CPU performs when an interrupt is detected. Okay, there are 3 missing statements, and write the letter of the missing statements from the table in the correct place to complete the description. Okay, so first then, well, at the end of each fetch-execute cycle, the processor checks if an interrupt flag is set. Right then, let's have a read of these. So the address of the interrupt service routine, ISR, right, is loaded into the program counter. Right, lower priority interrupts are re-enabled. The device causing the interrupt transfers data to the CPU. Right, the process identifies the source of the interrupt and checks the priority of the interrupt. Right, the ISR is incremented. So I think, well, let's have a read of this again. Right, at the end of each fetch execute cycle, the processor checks if an interrupt flag is set. So, when it says, well, checks if an interrupt flag is set, okay, this is just checking what has an interrupt occurred. Obviously, yeah, like 1, let's say, is yes, obviously, right, 0 can be false. So if it has been set, then I guess probably we want to do D, right, identify the source of the interrupt and check the priority. So yeah, let's just write D. Right, then if the interrupt priority is high enough, and actually, right, that's another thing where sometimes if you can understand just by reading, say the previous one, then you can actually, just read the next one. Because, here, obviously, it's talking about interrupt priorities, right? Number 1 is not talking about priorities, right? Therefore, that's kind of suggesting that, well, 2 is going to be sort of checking the priority or, something to do with the priority, which, of course, yeah, we can see here, right, checks the priority. Right, so if the priority is high enough, the processor saves the contents of the registers. Yeah, of course, well, that's so it can be reloaded again next time. And then I think what's going to happen is, well, then it's going to be the address of the interrupt service routine is loaded into the program counter. Because what we're saying is, well, yeah, let's try and do a diagram here quickly. Let's say we've got some running process, let's call it A. Let's say here, right, this is where there's some interrupt. I'll just sort of do this dashed line as the interrupt. So then all of the register contents, well, these are going to be saved to RAM. So we say what the PC, the MAR, MDR, right, CIR, yes, status registers, right, everything is going to be saved to RAM. Then what's going to happen? Well, then you're going to update the program counter, and you're then going to put the address of, you're going to put the start address of the ISR. So let's say that's going to be like 1000. And of course, well then, right, like this is also just code, right? So this will just execute. So of course, then it's going to go 1000, 1001, 1002. Yeah, just execute instruction by instruction. Obviously, when this interrupt service routine has finished, well, of course, yeah, then it's going to check, right, has there been any other interrupts by checking the interrupt flag. Yeah, obviously, if there has, it's going to sort of choose the one with the highest priority. But then, well, of course, obviously, it's going to continue doing that. And then when there's no interrupts remaining, well, this is where it can then load back in A. And obviously, what it's going to do, I don't know, let's say this had the program counter value 500. Well, then, of course, it's going to set the PC back to 500. It's going to set the MAR, right, the MDR, CIR, yeah, status registers, right, back to their original values. And then, of course, it can just continue executing, right, from the point it was at. Yeah, so then, right, number 5, when servicing of the interrupt is complete, the processor restores the registers. Yes, just loads them back in, right, so it can continue executing. Right, then 6, so I guess, well, we've said A. Right, so is it, well, lower priority interrupts are re-enabled? So I think, yeah, this seems possible. Right, the device causing the interrupt transfers the data to the CPU. So I guess, yeah, I think this is just, no, like, completely wrong. Right, then the ISR is incremented. Again, right, this is kind of wrong because, well, really, this should be the program counter is incremented. So yeah, I think here then that's just going to be B. And alright, as always, guys, yeah, that was a super long video, but hopefully it was useful. And if you have any questions, well, then just ask in the comments, and yeah, hopefully see you again in the next video.